So I will get right into the presentation. One of the big topics that I have talked about many times at this conference and many times at other conferences is scaling. Scaling is one of the biggest challenges of the blockchain space. Blockchains today are good at decentralization and they're good at security, but they are not good at being able to process more than a very small number of transactions. And up until a couple of years ago, this was okay, right? Because up until a couple of years ago, there were not that many users. But now, more recently, we've seen the number of people who want to use blockchains go up. We've seen the number of different things that people want to do on blockchains increase quite a bit. We have DeFi, we have NFTs, we have DAOs, we have enterprise applications. Just a lot of different use cases, a lot of different things that people want to do. And blockchains have to expand to provide space for all of these applications and for all of these new people that wants to use them. Now, there's an easy way to scale blockchains and there's a hard way to scale blockchains. The easy way to scale blockchains is to just say, increase the block size, increase the gas limit, just increase the parameters, and just let the chain process a much larger number of transactions. But the problem with this approach is it seems easy, but it sacrifices decentralization. Chains that try to scale by creating this one big powerful system where every single node needs to process a huge number of transactions can just very easily sacrifice all of their decentralization because very few people are willing to run nodes. Now, the other way to scale blockchains and the more sustainable way to scale blockchains is using layer 2 technology. So there are many kinds of layer 2 technology. So Bitcoin, for example, uses channels and has a lightning network. In Ethereum, there are applications using channels as well. There are a few applications using Plasma. But the most powerful and the most general purpose technology is called rollups. Now, the idea behind rollups is one that existed in different forms since at least 2014, but it was only really put together around the end of 2019. And in 2020, I made this post that is on the slide now, a rollup-centric roadmap for Ethereum. And what I talk about there is, next slide. What I talked about there is this idea that we need scaling right now. And it's going to take a long time for Ethereum itself to develop any kind of native built-in scaling. So what I mean there is what we call sharding execution, right? So sharding where every single shard can process transactions. There's a lot of technical challenges in doing this well. It takes a long time to do well. So we can wait. We would have to wait a long time for that to actually happen. Now, rollups are here today. The idea behind rollups was known since at least 2019. There are already several rollup projects that have launched some kind of alpha version that's already on mainnet. There's rollups work. We know that rollups can work. We know that rollups are fully general purpose. And we know that rollups can give a significant increase in scalability, up to a factor of 100 today. And data sharding, which is a simpler form of sharding that instead of trying to create very powerful shards that can process transactions, only creates shards that store and that verify data. This is a simpler kind of sharding, and with this kind of sharding, we can increase the scalability of rollups by another factor of 100. So there is a very clear path to scaling with rollups. Rollups can provide a lot of scaling. We know that they can provide a lot of scaling. And so this is the only logical scaling path for the Ethereum ecosystem. Next slide. So the difference between last year and this year is that last year, using rollups for scaling mostly was still just theory. So Buterin existed last year, but other rollups did not yet exist last year. But this year, there are many rollups that are on mainnet, and you can see how they have much cheaper transaction fees than the Ethereum network does even today. You can see, now, I expect that these numbers will continue to decrease even further. There are quite a few optimizations to how you can use rollups that decrease the amount of data that they need to store on chain, and so decrease the gas cost of rollup transactions. So Buterin, for example, already uses a lot of the optimizations. So it is already at least 30 times cheaper than the mainnet. Now, the Optimism and Arbitrum do not yet have these optimizations, but they're working on them. And when they do, Optimism and Arbitrum will also become much cheaper. So with layer 2s, we can already get transaction fees low to a level where at least lower than they were even last year. And then when we add sharding, we can decrease the transaction fees even further. Next slide. Now, there are many kinds of rollup technologies, and there are many kinds of technologies that are part of rollups. But there are two main types of rollups today. There's optimistic rollups and there's ZK rollups. Optimistic rollups use a technology called fraud proofs for security, and ZK rollups use zero-knowledge proofs for security. Now, optimistic rollups and ZK rollups have different advantages. I think the main advantage of optimistic rollups is that the technology is simpler, and so it is easier to build an optimistic rollup today, especially for general purpose applications like Ethereum smart contracts. ZK rollups, the complexity is higher. The benefit is that they have stronger security. They support very fast withdrawals. Instead of withdrawals taking 1 week, withdrawals can happen very quickly. And the technology, I think, is not quite there yet today, but I think within a couple of years, ZK rollups that support the full Ethereum virtual machine, the full EVM, will exist, and you'll be able to use them. So, in short-term optimistic rollups, I think in the medium and long-term, all rollups are going to become ZK rollups. I think once we have data sharding, sidechains are going to become ZK rollups. I even think that for enterprise applications, once this technology is finished, there is no value in having a separate private blockchain. You can just have a ZK rollup. If you use a ZK rollup that is connected to and rooted in Ethereum, then the fees will still be low, but you will be able to get the benefit of being connected to the Ethereum public blockchain ecosystem. Next slide. So, the technology is making a lot of progress, and there's a lot of people that are already starting to move their applications to rollups, or think about what their applications will look like in the context of a rollup ecosystem. But there is still a lot of work that needs to be done. So you can look at the work that applications need to do, and we can look at the work that needs to be done on the infrastructure side. So if you are an application developer, then you should be very actively looking at how you can move to a rollup as quickly and as safely as possible. Now, there are different applications, and different applications work differently. I think for non-financial applications in particular, moving to rollups is even more important because reducing fees is even more important. Because for non-financial applications, for applications that are not financial, users are not as willing to pay high fees for them. And also, a lot of these applications are fairly self-contained. So users within that one application are more likely to just talk to users of that other application. So like games, for example, right? So, for example, the Dark Forest game, this is the ZK game, the ZK Snark-based, like fully decentralized or fully trustless Ethereum-based game that Brian Wu came up with. That's an example of something that is on a test network now, but can move to a rollup in the future. NFTs can move to rollups. ENS can, well, on the infrastructure side, can move to rollups. And financial applications can move to rollups. Payments, so just using cryptocurrency for payments, can move to rollups. DAOs maybe will start living inside of rollups soon. So for different applications, the process will be different, and each application will have to think about whether it moves completely to one rollup, or whether it supports every rollup, or whether the application continues to live on the Ethereum main chain, but there are bridges to rollups. There are different ways to upgrade to rollups, and every application needs to think about this. Now, infrastructure. Infrastructure, so very core and very important applications or pieces of the ecosystem that every user, every application, or at least very many users and applications in turn use as part of using Ethereum. So ENS is the Ethereum name system, the decentralized domain name system on top of Ethereum, is a very important piece of infrastructure that a lot of Ethereum users use. I have an ENS name, a lot of Ethereum people have ENS names, a lot of my blog has an ENS name. If you go to vitalik.eth in a browser with ENS enabled, you can see my blog. So more and more people are using ENS. But the problem with ENS today is that everything is done on the main chain, and so transaction fees are high. So this is one infrastructure challenge. So moving rollups, or moving ENS over so that ENS can live inside of rollups. Light clients are infrastructure. If we want the Ethereum ecosystem to be decentralized, we need to have secure light clients. And these secure light clients need to be able to access not just the Ethereum main chain, but also rollups and bridges. Easy ways to move from one rollup to another without having to go through the Ethereum network and wait a long time and pay a very high fee. Next slide. So in E3668, Buterin, this is a proposal to allow both ENS and other applications to move to rollups. And the proposal is nice because it's a very general purpose. And basically, it allows the smart contracts on layer 1 to specify where applications or where information about layer 2 state can be obtained from. And it allows them to specify a function for verifying proofs of that information. So you can have trustless light clients that verify proofs of data in these layer 2 protocols, and so you can have ENS names that are registered and transferred and updated inside of layer 2, and whatever layer 2 they're in, users will be able to see the information using the same software. So very general, ENS names will be able to be moved to registered, subdomains can be registered in NS domains, can be updated in any rollup, very amazing. So this is a very important work in progress. Next slide. So light clients. Light clients allow a node to verify the blockchain without having to run a full client that verifies every single transaction by themselves. Light clients are very important for a blockchain ecosystem to be decentralized. And one of the things that we are doing with the proof of stake upgrade for Ethereum is we are adding support for a much more powerful light client system than is possible with proof of work today. So this is actually part of the Altair hard fork on the proof of stake beacon chain that is coming later this week. It adds this concept of sync committees, and it adds this algorithm that allows clients to, or that allows light clients to verify blocks that have been signed by these sync committees. And so it should be possible to have a secure light client, so be able to access the blockchain without trusting a centralized server inside a browser, on your phone, maybe in embedded devices, maybe as part of a bridge inside another blockchain. So a lot of advantages, but this light client system is also something that needs to be extended to the rollup ecosystem. So it's important that as we scale, we maintain decentralization, and all of the things that we are doing to increase the decentralization of the Ethereum mainnet also carry over and apply to everything that is happening in these layer 2 protocols. Next slide. Bridges. The challenge is basically that transactions inside of Optimism are cheap. Transactions inside of Arbitrum are cheap. And transactions inside of Loopring are cheap, transactions inside of Polygon are cheap. But what if you want to move some assets from Optimism to Arbitrum, or from Optimism to Loopring? This is harder. The only way that exists to do this for all layer 2s right now is to withdraw the assets from one rollup and then deposit the assets into another rollup. This requires an expensive transaction on the Ethereum mainnet, so it requires paying high fees. With bridges, it should be possible to move assets from one rollup directly into another rollup without touching the base chain, so without paying the much higher fees that there are on the base chain. There are projects trying to do this, there are ideas for how to do this, but this is still something that is being worked on. This is still something that needs to be tested and implemented much more. It is possible to, and we should be able to build much more decentralized cross-rollup bridges. So still a lot of progress has been made, but a lot more progress needs to be made. Next slide. So conclusions. Layer 2 is the future of Ethereum scaling. Scaling with layer 2s is the only safe and way to scale blockchains while preserving the decentralization that is so core to the blockchain concept. And EVM-compatible rollups exist, and they are very powerful because they provide scale. But they also preserve user experience, they preserve developer experience. So developing for a rollup is exactly the same as developing for Ethereum, with very minor changes, like for example, blocks might come at different times. But smart contracts work the same way, EVM works the same way. EVM-compatible rollups preserve all of these features of Ethereum, and they also preserve this really important property of Ethereum's decentralization. Now, at the same time, this is a work in progress. More work on infrastructure is still required. There's still a lot of things that applications need to do. There's still a lot of things that the ecosystem needs to do. But finally, the path to Ethereum scaling is now not just an idea. It is a very clear roadmap where many of the pieces of that roadmap have either already been developed and already been released to mainnet, or are well on their way in progress. And there's a lot more exciting work that is still left to be done here. So very excited for the future of Ethereum scaling. Thank you.